There is a file on your machine you were told to fill up. Every rule you added to it felt like progress. Be careful here. Never do that. Always format it this way. You were making Claude safer, more predictable, more yours. Then Anthropic deleted 80% of their own version of that file. Their coding scores didn't move, which means the work you did, all those careful rules, wasn't making Claude better. It was making it hesitate. I want to be precise about what happened because the headline is being repeated wrong. Anthropic did not say instructions stopped working. They said they had been over constraining their own model, and that on the newest models, a shorter prompt performed the same on their coding evaluations. So, this is not a story about deleting things and hoping. It's a story about a single test that tells you which lines in your file are earning their place and which ones have been costing you every session since the day you wrote them. By the end of this video, you'll know that test. You'll know exactly what to cut and what to protect. And you'll have run the command that does it for you. Here's the source. Anthropic published a post called The New Rules of Context Engineering for Claude 5 generation models. In it, they say they removed over 80% of Claude Code's system prompt for Opus 5 and Fable 5, with no measurable loss on coding evaluations. Tariq Shihpar, who works on Claude Code at Anthropic, put it more bluntly. He said the new models want a smaller system prompt. And on examples specifically, the thing everyone was taught to add, he said they tend to constrain it because the model is more imaginative than the examples we give it. Now, one clarification that matters. Claude Code's system prompt isn't one block of text. A community archive that pulls these strings straight out of the shipped binary counts more than 500 separate pieces, assembled differently depending on what you're doing. So 80% is a shape change, not a single deletion. And this cut applies to the Claude 5 generation. Older models still get the longer, stricter version because they still need it. So why would removing instructions leave performance unchanged? Because your rules don't arrive one at a time. They all arrive at once in every session, and they have to agree with each other. Anthropic gave the exact example from their own prompt. The old line said, in code, default to writing no comments, never write multi-paragraph doc strings or multi-line comment blocks. One short line max. That's a rule written to prevent a bad outcome. And it works until you ask for something reasonable, like documenting a tricky function properly. Now Claude has your request pulling one way and a hard prohibition pulling the other. It stops to negotiate before it writes a line. Here is what that rule became. Write code that reads like the surrounding code. Match its comment density, naming, and idiom. Same intent. But now it's a judgment instead of a ban. And the judgment fits every file in your repo, including the ones you hadn't thought about when you wrote the rule. Anthropic laid out 6 shifts. I'll give you all 6 quickly because 2 of them are where all the practical value is. 1. Give Claude rules becomes let Claude use judgment. That's the comments example. 2. Give Claude examples becomes design better interfaces. Instead of showing it 3 worked examples, give your tool a well-named parameter with the valid state spelled out. The shape of the tool teaches it more than the demonstration did. 3. Put everything up front becomes progressive disclosure. Don't load it until it's needed. 4. Repeat yourself becomes say it once, clearly. The old habit was stating the same rule in the system, prompt, and again in the tool description in case it got missed. On the newer models, the repetition just competes with itself. 5. Memory in Claude.md becomes automatic memory. We'll come back to this one. It's the reason your file was getting bloated in the first place. 6. Simple specs becomes rich references. Their line here is worth quoting exactly. A HTML mockup of a design will generally produce better results than a description of the design or a screenshot. Stop describing the thing. Hand over the thing. Quick pause, and I'll keep it short. Everything up to here was the news. Everything after this is the part you actually run: the test, the cut list, and a real before and after on a real repo. If the last 5 minutes changed how you think about that file, that's what every video on this channel is built to do. Subscribing on YouTube is free, and it's the whole reason I get to keep making these. If you want to go further than free, becoming a member supports the deeper builds directly. And I post the same work on Facebook and Instagram at Hyper Automation Labs if that's where you live. That's it. Back to the file. Now, the part that makes all of this actionable. Anthropic shipped a command called /doctor. I pulled the instructions it runs on. They're extracted from the shipped binary and published in a community archive. And inside is one sentence that governs everything. Could a session working in this repo reconstruct this by reading the code? If yes, cut it. If no, keep it. That's the whole test. Read any line of your Claude.md and ask whether Claude could have found it out with a couple of tool calls. Running ls opening package.json. Typing help. Because here's the thing about a line Claude could have derived. You're not saving it a lookup. You're paying for that line in every single session. Forever. Whether or not it's relevant to what you're doing today. And there's a second sentence right underneath, which I like more than the first. When unsure, keep it. So here's what that test throws out. This is Anthropic's own list, not mine. Cut your directory and file layouts. ls already shows that. Cut your tech stack and dependency lists. Your package manifest already says it. Cut standard build, test and lint commands. Cut API signatures, type definitions, and schemas you copied out of your own source. Cut architecture overviews that read like a README because the code base is the README. Cut generic best practice. Write clean code, handle errors properly, add tests, and cut any rule that a lint config, a pre-commit hook, or a CI check already enforces mechanically. If the machine already blocks it, you don't need to also ask. Now the other list. Keep your gotchas and failure contracts. The things that look safe but aren't. Keep design rationale. The why that the code can't explain. Keep conventions that differ from the defaults. Because if your repo does something non-standard, reading the code teaches the wrong lesson. Keep agent directives and safety critical prohibitions. Keep repo etiquette, branch naming, commit style. Keep domain glossaries. Keep the build commands that nobody could guess. And keep pointers to context that lives somewhere else. Look at those two lists next to each other, and you can see the shape of the new file. It isn't a description of your project. It's the set of things your project would lie to you about. Lists are easy to agree with and hard to apply, so I ran it. I built a repo, a subscription billing dashboard, next.js, Prisma, Stripe. Then I wrote its Claude.md the way we were all writing them in 2025. Project overview, tech stack, full directory tree, commands. The database schema pasted in, 16 code style bullets, API conventions, a deployment runbook, a release checklist. 174 lines. Nothing unusual about it. Then I ran the real command against it, report only, and let it tell me what it thought. It came back with this. That file was costing about 1,585 estimated tokens in every session. Roughly 56% of it was reconstructible from the code. After the cuts, about 558. That's 1,000 tokens back. Every session. A 65% reduction. Now, that's my repos number, and I wrote it deliberately bloated. So don't expect the same figure on yours. And these are estimates. The tool is counting characters, not measuring a live session. But the numbers aren't the interesting part. Three things it did are: first, it flagged my directory tree as stale. The tree in my file listed a public folder, a tsconfig, and a next config, and none of the three existed in the repo. I hadn't done that on purpose. I'd just written the tree the way you'd expect a project to look. Its line was, "A stale map is worse than no map." And that's the quiet argument against documenting your structure by hand. A handwritten tree starts rotting the moment you write it. LS never does. Second, and this is the one that taught me the most, my style section had a bullet that said, "Use named exports rather than default exports." Read that cold, and it looks exactly like the generic style advice we just agreed to delete. It kept it, because Next.js app router requires default exports for page and layout files. That rule doesn't match the framework. It deliberately contradicts it. Which means if you deleted that line and let Claude learn from the code would teach it the wrong pattern. That's the real boundary. It was never about how generic a rule sounds. It's about whether the code base alone would lead you to the same conclusion. Third, I expected it to move my gotchas section out into a smaller file. It refused. Three of those 6 lines were never do this rules. And it wouldn't put a safety rule somewhere. It might not be loaded at the moment it matters. A slightly larger file beats a prohibition that isn't in the room. So if most of it leaves the root file, where does it go? There are 4 places, and picking correctly is the whole skill. The root CLAUDE.md is for what's true everywhere, every session. Universal constraints, style that applies across the repo, and every safety critical prohibition. This file should be short, and it should be almost entirely things that would surprise someone reading your code. A Claude.md inside a subdirectory loads only when Claude is working under that directory. If a convention only applies to one package, that's where it belongs. A skill lm, a folder under .claude/skills with a skill.md inside, is for task-specific work. Deployment steps, a release checklist, an API reference. Only the one-line description stays in context. The body loads when it's actually invoked. In my test, the deploy runbook moved here, and its resident cost dropped from about 180 estimated tokens to under 40. And a rules file under .claude/rules takes a paths setting in its front matter. So it loads only when Claude touches files matching that pattern. Your migration rules can sit dormant until someone opens a migration. One hard exception. And it's worth repeating because it's the easiest mistake to make. Never move a never do this rule into a lazily loaded file. A prohibition that isn't loaded is not a prohibition. Now back to Shift 5 because it explains how your file got so big. For a long time, the way you told Claude something durable was to put it in Claude.md yourself. So that file became everything at once. Architecture notes, your preferences, corrections you'd repeated 3 times, project status. All of it always loaded. That's been split apart. Claude Code now keeps its own memory. One file per fact, each tagged as being about you, about feedback you've given, about a project, or a reference to somewhere else. Facts link to each other, and only a short index loads each session. The full memory is pulled in when it's relevant. But here's the line in those memory instructions that made the whole picture click for me. It's told explicitly not to save what the repo already records. Code structure, past fixes, git history, or anything already in Claude.md. Read that next to the derivability test and it's the same rule, applied twice. Memory won't store what Claude.md should hold. Claude.md shouldn't store what the code base already holds. Every layer is being told to stop repeating the layer beneath it. That's the actual idea behind all of this. Not less context, less duplicated context. So 4 steps, And the first one takes a minute. Open Claude Code in your biggest project and run slash doctor. Read what it proposes. It reports before it changes anything, and it quotes every line it wants to remove so you can put it back. Then go through your file with the one question. Could a session reconstruct this by reading the code? Delete every yes. When you're unsure, keep it. Then take what survived and ask when each part is actually needed. Everywhere stays put. One folder goes to that folder. One task becomes a skill. One file pattern becomes a rules file. And prohibitions never move. I put all of it on one page. The cut list and the keep list side by side. The one sentence test. The 4 destinations with their loading rules. The exact before and after from my run. And the mistakes that will cost you a safety rule. Comment the word lean, one word, and my bot sends it straight to you. Free as always. Real talk. Most of you watching haven't subscribed. On Facebook, subscribe is the supporter button. See, that's what keeps the lights on here. On YouTube, it's free and it tells the algorithm to send you more. Subscribe to support us. And if you're just getting started, my step-by-step beginner guides are linked below. Here's what actually changes. And then stop maintaining the parts you deleted. That's the part people miss. The tree, the stack list, the command list were never just costing tokens. They were costing you the small tax of keeping them true and quietly lying to Claude whenever you forgot. You've been managing a document. After this, you're maintaining a much smaller thing. The short list of things about your project that nobody could work out on their own. It's a file you can read in 30 seconds. And it's the only version of it that stays true. Comment. Lean for the one-page kit. We're on YouTube, Facebook, and Instagram as Hyper Automation Labs. See you in the next one.